These are the solutions for the first practice quiz for quiz 5 in the third trimester of Algebra 2. So on 1 and 2, you want to use these conversion factors. And if you're taking it from degrees to radians, just know that your factors are 2 pi and 360. So all the way around the unit circle is a length of 2 pi, and that corresponds to 360 degrees. So you just kind of think of canceling. I want to cancel the degrees out here by multiplying by 2 pi over 360. So these degrees will reduce, so to speak. And you want the degrees on the bottom there when you do this. And basically what you want to do is do 135 times 2, leave the pi out of it, divide by 360, and then just convert that to a fraction. So that ends up being 3 pi over 4 when you convert it to radians. So leave the pi out, treat it like a variable, and then just do 135 times 2 over 360. Now 4 pi over 3, you want to think of going the other way, multiplying by 360 over 2 pi. And again, we're going to leave out the pi's this time because they actually cancel. And then just do 4 times 360 over 6. And that's 240 degrees. So in both, you're going to leave out the pi from the calculation. And just remember that 2 pi is 360 degrees. And so if you're taking it into radians, you want to have the degrees cancel, so to speak. One in the numerator, one in the denominator. Then if you're taking it from radians to degrees, you want to have the radian mark of 2 pi in the denominator so that those pi's will drop out. Using the unit circle, find sine of pi. So you can use your calculator to do this. You just need to make sure that you are in radian mode. So if you were doing something else, in degrees, let's say, then you'd have to be in degree mode. So sine of pi is 0. That's the same as saying sine of 180 when you are in degree mode. Oops, it is the same thing. 0. So we're going to go back to radians mode because most of what we're doing is radians mode. So that is, if you were looking at all the way through 180 degrees, the triangle actually collapses. So the opposite side is 0 and the hypotenuse is 1, making it 0, which I should have kept that right up here. So the next problem deals with this right triangle here that swept out along the unit circle a length of 3 pi over 4 radians. So how do I know that's 3 pi over 4? Well, it's increments of 45 degrees are pi over 4. So that's 3 of them. So there's one here to make 90, and then another one to make 135. So here's the x and the y that you get from doing sine and cosine. You can also just memorize, I shouldn't say memorize, but have as a reference the decimal equivalents that exist for these special right triangles on this page. Just have this written down. Then you can just use your calculator to do this. So cosine of 3 pi over 4. So that is negative square root of 2 over 2, and so on and so forth. So sine of 3 pi over 4 gives you positive 0.7071. So that's another way to approach that. And that question is going to be on one of these special right triangles and their location within the unit circle. So you see there's 12 of them that I could ask you about. Okay, so 5 is getting at, there's 3 questions dealing with what I call arc length multipliers. So all arc length is a portion of the circumference in a circle. And so are we dealing with a portion that's given in degrees? Are we dealing with a portion that's given in radians or in minutes? So the theta is the given central angle or the given angle that's swept out. So notice on this one, we are dealing in degrees. So the formula that we're going to use is this multiplied by 2 pi r. So 90 over 360 times 2 times pi times 7. And what does that give you? I guess as a decimal would be the best way. And then you just simply type it in to your calculator, pi times 7. And that's about 11.0 rounded off centimeters. So this is a case of the degree multiplier with arc length. So you're going to have one each on here, as you'll see coming up. So what is the measure of this angle that swept around? So again, think of this picture here, except we're coming all the way around to this. So back up 45 degrees from 360. That's one way to think about it. So that's 315 degrees. Or back up pi over 4 from 2 pi. So you're doing 2 minus 1/4, and then just converting that to a fraction. So 7 pi over 4 is the radian measure. So remember, all the way around is 2 pi, back up pi over 4. So you're doing 2 minus 1/4. Treat the pi as a variable, and you will have it. Or you can just convert 315 degrees to radians. Find the tangent of the angle. So tangent of 7 pi over 4 is -1. And I should have included that in this, that you will have those as well. And I don't need to expand that decimal. Obviously, 1 is 1 and -1 is -1. Those will be as well. All right. So a circle has an arc length of 3 pi with a central angle of pi over 4. So here our multiplier is theta over 2 pi. So theta is the given central angle. So here is now some people will say, don't the 2 pi's always cancel? Yep, they do. And you just have theta times r. That's acceptable as well. And I should have, back on this one, put AL on this side, arc length equals. We were calculating the arc length there on that one, which is 11. All right, so we're given the arc length is 3 pi. So we'll come over here, equals theta, which is our given angle, pi over 4, times r, which we don't know. So I'm going to use this reduced version here. Well, the pi's drop out if you want, or you could multiply both sides by 4. I always think about getting rid of denominators because it helps me see things clearer. Okay, so r is 12. The pi's drop out, r is 12. And then 9 is dealing with the multiplier of the minutes. So theta over 360, or I'm sorry, 60, not 360, 60 times 2 pi r. This is arc length again. So we have 15 over 60 times 2 times pi times 16. And that is about 25.1 feet. So that's the third multiplier which is minutes or seconds, however you want to think about it. This here just deals with the 22 plus, so these will be half of a circle, and that's the radius right there. So if you extended it up here, you could see that that's the radius. So instead of 2 pi r, it's pi times r. And this is always going to be this way. So plus pi times 12. And that will be 59.7 feet. Again, instead of 2 pi r, it's pi times r. And this is your r. So if you extended it up, you would see that that's half the circle. I mean, if we made a whole one, you know, we're just dealing with these two pieces. So it's just pi times r. And those are the solutions for the first practice quiz for quiz 5.